In an Apple shop, 40% of the customers buy an iPhone. In a random sample of 24 customers, find the probability that more than 16 buy an iPhone. The percentage of customers who buy an iPad is 25%. Find the probability that shop sells the first iPad to its fourth customer. Find in a random sample of 24 customers, more than 16 buy an iPhone and at least 5 buy an iPad. Assuming the selling of an iPhone and an iPad are independent events. Okay, so quite a lot of things in this question. Let's just do stage by stage. Let's look at part A. Let X be the random variable, the number of people out of 24 who buy an iPhone, or the number of customers might be a better word. So X is binomially distributive, N is 24, and the probability of success of buying an iPhone is 0.4. We want more than 16, so we want the probability that X is greater or equal to 17. To do that, we need to use a PDF. So let's just go over to this for a minute. So going to our GeoGebra, okay, so we want more than 16, so that's going to be 17 or more, so we need to sum these probabilities together, setting N to 24 and P to 0.4. Okay, or if we're going to consider the community distribution function, and to do that you need to click this one here. We need to find 16 or less, and then do 1 minus 16, the probability is 16. So there's a diagram of that, but we will need to sum these probabilities up, and we will need to do 1 minus the probability X is equal to less than or equal to 16. So the probability X is greater than 17 will be 1 minus X is less than or equal to 16. So that would be 1 minus 0.9978 from here, which gives me 0.0022. Not much of a chance, very, very small. Okay, the percentage of customers who buy an iPad is 25%. Find the probability the shop sells the first iPad to its fourth customer. So let I be the customer who buys an iPad. We require the first 3 customers not to buy an iPad, and the fourth to buy an iPad. So that's going to be the probability of not I times I. The probability of not I is 1 minus the probability of I, so it's going to be 1 minus 0.25, which is 0.75. So we want 0.75 times 0.75 times 0.75 times 0.25. That gives me 0.75 cubed times 0.25, which is exactly 27 over 256, or 0.1053 significant figures. For the last part, in a random sample of 24 customers, more than 16 buy an iPhone and at least 5 buy an iPad, assuming selling an iPhone and an iPad are independent events. Well, we've already calculated the probability of more than 16 can buy an iPhone in part A. So let's look at part B. Let Y be the random variable. Sorry, let's look at this by the iPad, sorry. Let Y be the random variable, the number of customers out of 24 buy an iPad. Y is binomially distributed 24, 0.25. We require the probability of Y being greater or equal to 5. So using the PDF, so we can go back to our GeoGebra probability calculator. Let's go back to the binomial. And we now need to set this one here, the probability of success now 0.25, and we want more than 5 or equal to 5, so that's going to be all those. So we'll need to sum all these probabilities up. Or if they're doing the community distribution function, then we'll need to put in 4. Okay, and do 1 minus that number. Okay, so we need to sum those. Or easier would be to do, using the CDF, is to do 1 minus that value from the table. So the probability y is greater or equal to 5 is 1 minus the probability y is less than or equal to 4. And that gives me 1 minus 0.2442466 from the table, which gives me an answer of 0.7534. But we want the probability of more than 16 buying an iPhone and at least 5 by an iPad. So more than 16 by an iPhone is probability x is greater or equal to 17 from is equal to 0.0022 from part A. We require probability of x being greater or equal to 17 and y is greater or equal to 5. We've got the word and in here. So it's going to be 0.0022 times 0.7534. These two events we're told are independent, so we just multiply them together and we get an answer of 0.001657, which is 0.0016623 significant figures. Okay, so this has been a probability question, binomial probability question of combining two different distributions together in order to calculate a final probability. I hope you've understood, and I thank you very much for watching.